Okay, so now I'm going to share the screen and then you can have access to it. Okay, please, can you see the screen now? Can you see my screen now?
Yes, sir.
Okay, all right. So we're going to start. Um, yeah, so the first one, if you have the question, as I say, so the help files, how do you get help? Well, first of all, we said that this thing is in mass package. So maybe you come to here, you look for mass, right? And then you take it like this. Let me take mine again. Once I take it, when you come here, you see libraries, so and so. So I'll copy this and paste
Sir,
it
please.
in my Word document, right? So do you see my Word document now? I
Sir,
think
please, no.
no, I have to share that one too
Sir,
again.
please, no.
Okay, so let's see. I have to alternate. Okay. So let's say this is your Word. I'm sure now you see it. Okay. So Department of Statistics and Actuarial Science.
Sir, please, you can't see the screen.
You can see the screen.
No, please.
No,
It's
I've
blank.
shared it. Is
So we
anybody
can see.
seeing it now?
Sir,
Yes.
please.
Yeah,
I can see.
Please, are you seeing my screen, the Word document?
Yes, sir.
Yes,
Yes.
please.
Okay. So yeah. So Actuarial, what is it? Act two. You write, let's say your ID number. So let me say your ID number is this, boldly written, okay? And then maybe Actu302, intro to intro to actuarial computing. So please, some did not even write their ID numbers. So if I see that, I deduct 2 marks from because then you give me problems. Because when you finish your thing and we download, assuming I did not ask you to, what is it, print it and bring it, then I need to go and search through and see whose work is this. So please, make sure you write your ID number, and your ID number must be on the top page of every sheet. So if you like, you do it over here too, okay? You put it as what is it? What do we call it? A header, and then it will be there all the time for me to see. So that's it. So the first one, as I'm saying, is question one. Okay. In question one, you first of all will talk about light. Oh, no. So I need to go and copy from I copy from my console. So the first this and it is even easy. I said this in class that you even put your code in a box. It makes it easier. Okay, so that it is distinct from your word. So this is library. If you do this, then you will have mass loaded into your working environment. Okay. Then the next thing is that you need to what? Do the help files, right? So that help will be this. Okay. To get the help, you do that. Help is 2. Okay. If you run this in R, that will give you the, so let me go back. I need to be alternating between this and R. moment. Okay, so let's see. Okay, so this is what I mean. When you come here, you do what? Help aids. Aids to like this. So when you do this help, it tells you that this is what? The Australian data, so and so, right? What do? You can, so this is, if you even copy, that's fine. The data is on patients of what? So and so. So the health, if you are describing it, that's the description. So the data is the Australian AIDS survivor data, and it contains what? Data on what? Patients diagnosed with AIDS, right? So you copy that, but that one is not code. Okay, so you paste it outside. Okay, outside you paste it outside. So like this, I have to be alternating between the distance. So just bear with me each time, but you'll see it once I do it. Okay. So have you seen it? So the data, so you can see that ACE2 is the Australian. Okay. So you see that this one is survival data. Okay. Then the data contains, so something like that, so that it contains information on patients what diagnosed with so and so. So that's the description. You are done, right? That's it. Okay. Then we say identify the data structure. So the data structure is what? Is a data frame. Okay. So that if you want to do it in R, you can use the str to help you. Okay. So there in R as well, what you are going to do is that you do structure of the data. So in this case, A is to, okay, like that. And it displays over here, it says it's what? A data frame, so and so of what? 2008, so and so. So here you copy just a bit of it. Okay. This one is not much. So if you like, you can copy all. Okay. And then you go and paste in your Word. This is code. So just put it in what? In a, what is it? A box. Okay. The codes and results, you can put it in a box. It makes your this thing nicer, right? So please, everybody, unless you are asking question, you must mute yourself. Okay, don't give me that job. I have to go and mute everybody so that I can concentrate on what I'm doing, please. Okay. Let's see. So which one am I sharing now? Let's see. So look at it. So you have it like this, okay? The codes like that. And then this one, because I asked you what is the data structure. So the structure of the data is what? It's a data frame. is a data frame. And the types are, if you look over the integers, okay, you can put that one into bracket. That is die.
Sir, please, we cannot see your Microsoft Word.
You can see.
Sir, we can't see your screen.
Is it only you?
Yes,
or?
sir. Sir, I can't see you.
Who else?
Hello, please, I can see.
Yeah, we can see.
Yeah, maybe it's your connection.
Semi, I cannot see.
So those that are integers, you can put them in what? In a bracket like that, right? I'm not saying that everybody should do it this way, but you can do your own that way, age, right? But the key thing is that you see that if when you finish, make sure that your font themes are different, right? From this one. These ones, I said they should be in Korean new. But if they are even in this one, it's okay. Because this is it's a Verdena or so. No, Lucida console, which is also fine. You know, but this cannot this one cannot be in the same font theme as your this is area, so it's fine. Okay, but it shouldn't be the same as what you have in the box. Okay, so that's it. So and then factors. Sorry, the data structure. Yeah, and the types are integers. That's direct, def, so and so, and then factors. So area 11. Okay. Factors. The factors you can talk about sex. You can talk about what? Status. And what again? Three cards, right? Like that. Okay. So this will tell me that you know what you are talking about. That you know what a structure is and you know what the types are. Is everybody okay? So without that, I wouldn't know whether you understand the concepts or not. So that's what I expect from you. Okay. So that I think that concludes question one. Okay, then you come to two. In two, we say that from your identified data types for the variables, select one variable from each distinct data type and choose appropriate descriptive statistics to describe each of the selected variable. Comment on your results. Okay, so here the distinct variables were types, data types were what? Integers and what? Factors. So you select one variable from each and describe it. That's all. So when we give you a question, please make sure you read and make sure you understand before you start. Okay, so if let's say I may choose to what? I may choose to analyze what? Maybe die. Hello? Yes. Good evening. Uh, yeah. I'm ready. Yeah. My office, my child. My tutorial. Okay. Yo. I'm watching. Okay. So Dike. Okay. That is for integers. So for integers, maybe I choose Dike. Or age. Let me choose age. It's better. Oh. Okay. So I'll choose age, and then for factors, I'll choose maybe sex, right? So this is what I have chosen, and that's all. Some of you were now going to assign whatever age, and you have been given a data set. The data set has description. Then you now go and number them as S1, S2, or A1, which has no bearing. So if I'm marking, if you are talking about A1 and A1 is age, I have to flip back before I can understand what you are doing. You know, so you whatever you are doing, I said even names. Name your object such that it is the name is a reflection of what actually is contained in that variable. Okay, so please make sure whatever you are doing, you follow the concept. Otherwise, it gives an indication that you were not coming to class. And from this, I knew those who were not coming to class and those who were coming. Okay, and when I finish, I will tell you some of the things I have seen. And that's for the punishment. I already told you. So you cannot come here and be begging. I won't even listen to you at all. So let me now go to R, and then we check what is it that we want to do. So is everybody okay? We've chosen what we want to work on. Are you okay? Please, are you fine now? I have shared the R screen. Are you seeing it now?
Yeah.
Yes,
Good.
yes, sir.
Okay, so I can continue. So we are left with the second one. So the first one, we are done. Question one, we are done, right? Oh, it's not hypothesis testing. This one we are doing what? I discussions. Okay. So two, we said we are going to look at sex and age. So we have to choose descriptive statistics that we think will be okay for age and sex. So for age, it's up to you. You may choose a histogram, you may choose a box plot. What else? Maybe a stem and leaf. So any is quantitative variable, right? Now, so here you now see how people are doing. Somebody will do a box plot for age. I don't understand. Sorry, what is it? A pie chart. I don't understand. You know, so age. We gave you age, right? And if you look at age, it is not age, right? Okay. So age is what is it? A category, sorry, quantitative data. So if you like, you do a box plot or maybe a histogram, okay, so that you can now, and for histogram, I said, and most of you were also doing the same thing. So you do your histogram like this, it looks like this. You have to now label it correctly. You cannot be putting age to age. Nobody will know what it is about. So here I was a bit lenient. In exam, if you do it, I'll allocate marks for all of them. So if you don't do it properly, you lose the marks. Age maybe in years, like that. Okay. So this is okay like this. Okay. Then so in now, I expect to, sorry, in your output, I expect to get this as well as your histogram. Okay, so I'll allocate marks for the code and then also what you did. Okay, so I can integer age. I do it like that. So I'm coming now. Share my screen, but I mean, I'm not going to be alternating between here again. I will just explain because now you know what I require of you. right? Okay. So just a moment. Share this for you to see. Okay, so you will see what I think if you are here, you see, but you need to now copy the box plot, or sorry, the histogram, and paste it in the Word as well, in your Word document. Okay, so here, like that. Okay, so that we have what? Your code as well as the what? The results. Then we say comment. So you cannot just put this one here and just go. That's what some of you were doing as well. Okay, you have to comment on it. So how does it look like? How would you explain this? So in this case, well, you know, there's a bit of some skewness, but it's approximately we can say is normal, right? Sort of, you know. So, but I just want a comment. If you use box plot to, that will also give you something else. Okay, so you can use box plot that can also help you to know the distribution even more than what a histogram will give you. Okay, so that's another way to look at it, and that you use a box plot as well. So this, we can say that the age distribution, is approximately what? Approximately normal. That is, you don't have okay. You don't have let's say significant outliers in them as well. You don't have very large let's say somebody is about 120 years, okay, old, or somebody is very close to they are all around what? Somewhere around the mean. So we can say that it's approximately normally distributed. So I'll mark the code, I'll mark the results, and then also your comment on it. Please, if you join, make sure you mute yourself. If you need to ask questions, you can raise up your hand or just talk. I'm okay with it so that we answer you. So anytime you don't understand anything, just let me know. Okay. Now the next thing is that so we are done with the numeric or the integer data type. Now we have to do what? The factor. Okay, type, which is text. So that one is categorical, right? So then you have to choose another descriptive statistics that you can use. I must say that for the it is not only diagrams or pictorial descriptive statistics that you can use. You can also use the summary statistics, okay, like what we did in Describe, to get those values, and then you talk about it. So it's not only pictorial ones, okay. So for sex, so this one is age, right? Age. So we are done with age. Then for sex, maybe you want to you can somewhere using prop table, which means you get the proportion of males and female, and then you talk about it. That's fine. Okay. Some will use pie chart. Also, then you talk about it. It's okay, because I did not specify. I said use any descriptive statistics of your choice. Okay, so one way is that we can construct a pie chart, or maybe we can do those prop table, right? And or let me just use a bar plot. So if you are using a bar plot, then you need to table text. So you have to go to 8, 2, okay, and then you sex. So if we do this, it's going to give us all the number of females, 89, males, 2007 something, right? So we can do a pie chart and put this table in there, right? And then we run it. Okay. So that gives us male and female. Okay, and if you want, or if you want to use the table as well, this table, we can even do that prop table here. Okay, so if I do this, I can divide by the number of rows of what? Of A's2, or the length of the sex, whichever way you want to look at it. Okay, I can do this and multiply by 100, and that will give me the percentages. Okay, so I multiply this by 100, that will give me the percentage. Okay, so the percentage of females is what? 3.13%. For male is what? 98.6 or 98.7%. And then you talk about it. So whichever one you use, that's your choice. Okay, just do it like that. If you have any question, please, you can ask at any time. Okay. All right, so let me move on. Next was I think we are done with number 2. Yes, so we are done with number 2. Then number 3. Any question? Is everybody okay up to this point? So number,
Yes, sir.
Yes, sir.
okay. If you have any question, you can ask anytime, okay?
Hello, sir.
Yes, I'm listening.
So describing the text, let's say if you use the function summary, if you use summary, it will output you a number of females and a number of males. Can you just use that one to just describe it?
Yes, it's the same as the table that I did. But I don't encourage the use of summary for even though you get it, I don't encourage it because it's not a right. You know, when you use summary for categorical data, for the numeric data, you are going to, so it's the same as the tabling. But because we use summary for getting summary statistics on the numeric data types, I don't advise that you use it. Okay.
Okay, sir.
Yeah. So just use table. It's better to use that. Yeah. But it's perfectly okay. You can describe them with the frequencies. That's fine. Any question? Okay, so we can move on. The third one, you were to randomly select 1,000 observations from this data, and you have to provide your R code and show the first few observations of your sample data. Okay, so number 3 is that you sample 1,000 observations, and surprisingly, some were not able to do this. Sample 1,000 observations from the data. We did this over and over and over again in class. So if we give you work and you can't do it, then it means you all the assignments that you were doing and so forth, somebody was doing it for you. So no wonder that some of you, even what you submitted on Sakai is not what you printed for us. You know, we can't tell you that don't do this and you want to do it. So when I see it, I just delete you from Sakai. I delete your index number straight away. So next year we'll give you F. Then next year you come and reset the course.
The sound will come.
Okay. So let's move on. So how do you sample this? You've told us that this is a data frame. So it means that you have to sample rows, isn't it? Yeah, so you will need an index to do this sampling. Please, there are other ways of using it. Somebody was trying to use TDVerse and so forth. When I saw it, I was happy, but the person did not continue. So yes, I've taught you the basics, but you can explore. Okay, I can't go on and use ggplot and TDVerse and so forth to do this because we must. It's just one semester, so yes, but it's up to you to explore to know the others you can use. All right. So the thing is that you start. Okay, I usually in class this is what I was doing. So you have to sample. Okay, and here my x will be 1 to the number of rows that I have in this data set, like this, is 2. Okay, then the size, what is the sample size I want to use? 1,000. And remember this one, we don't want to select the same row twice. So I can leave it like that, and so that replace is what? False. Okay, so this is just an index. So somebody has said sample from your data, your observations. Somebody will do this and do some, what is it? Show the first few observations, then head of this. Of course, you know, I'll mark the second one because it doesn't depend. But this is all your data. The data we are dealing with, if we, over here, let's say in 1, if we look at the head of that data, it's not numbers like that. That's the head of that data is like this. So with the sample that you get, we expect it to be in that tabular form like this one. Okay, so when you do this, let's say you name it my sample. Okay, your sample, then you need to call A's data to, okay, and then you pass in your indicators, which is your sample result like this. Just this simple thing, and there it is. So now, if you do my head sample, that's the second thing we said you should do. It's like this. So the first observation you selected was 1,172. The next one was 930. The next one 1,763, 1,952, 51, and so forth. So that's it for the 3. Not anything. It's not anything difficult. Just like what we've been doing in class. Okay. And then 4. If you have any question, please ask before we move on. Okay, so I assume that nobody has any questions, so I can move on now. Okay, so now 4. 4, we were to compute the survival time of AIDS patients and name it as a new variable. I don't understand why people were so worrying themselves about it. We said, first of all, I said study the data. So when you come here, you have to, the Australian survivor data. The data frame contains what? 2 A so and so columns. What are the variables? State, grouped state of origin. Sex of the patient. Diag is Julian, that is date of diagnosis. And death, date of death or end of examination or observation. So if you have all this and then we ask you compute the survival time, what do you need again? It is not about any formula like your survival functions that I did not say survival function, I said survival time. Okay? Survival time of the patient. So the date that the person was diagnosed to the date that either the observation end or the date of death. And the Julian is a date. Okay? It's just the same date that we use, but that is only in numbers. Okay, so you don't need to even convert it or anything at all. Okay, so somebody will say, we have not taught us how survivor time is done. Survival time is just if you come into this world, your survival time will be the next time you die. The difference, that's all. So I don't need to teach you this one for you to be able to do it. Now, survival is a function. So if you want to use that, you must what? That's why I've capitalized mine, right? So here, if I want my survival time, so I call my sample, okay? And then the death date, that will be the end. Then I subtract what? The, what do we call it? The date that the disease was diagnosed, right? This. When I do this, I'll have my survival time. If I want to get to know how the survival time is, I can plot it in a histogram, okay, and see how it looks like this. And there, that's my sample survival time. It may be different from yours because what? We did random sampling. So we don't expect that we get the same thing. Okay, but essentially what we said was that you must attach this to your data, your sample, and then name it as a new data frame. Okay. Now here, people were using the function attach. Please, you have to read the question well. So my sample, let's say serve, okay, or let me just name it. My sample serve will just be what? I'll call my other, some of you were using, so just data frame. I said it should be a data frame, right? So you call this and then you add survivor. Survivor, like that. So, there. Okay. Then I said do this. So when you finish, you can now show how this data set looks like. There it is. So you see now it has added the survivor or attached the survivor to your data. So that's it. And that ends the question 4. You must ask. If you don't understand, please ask.
Hello, sir.
Yes.
So please, what if you use cbind dot data
The cbind is for matrix. I did mark anyway, but I mean the correct thing is that you use a data frame because I mentioned that it should be a data frame. Okay. Any question again?
So what about the dollar sign and you assign the survival to it?
The dollar, you can also do that. Yeah, that's
Okay.
also nice. Yeah. You can call I think what he's saying is that we can also, so that you don't need to name it again. So that's also true. So you could have called this and then done, let's say, survivor, and then you assign the survivor to it. So that's nice. There. Okay. So now if I do this, yeah, survivor is there. But remember the main one, the survivor was not there. So that's another way to go about it. Okay, good. So let's move on so that we finish early. Now 5 is that compare the survival time according to what? The status of the patient. The status of the patient. Remember that if you come, so you must study the data. There is what? Status, which is whether the person is what? Alive or what? Dead, isn't it? So what we are saying is that you must group the survival times, the one that you have computed, according to those who are alive and those who are dead. So this one, the easiest way around is to use box plot, right? But that's not the only way. You can compute your summary statistics and group them for both. It depends on you because I wasn't specific. So one way around is to do a box plot, your data. Now that we have done it, it can be any of them, my sample or what? My sample set. So let me just use that one. And then what are you looking at? You are plotting what? The survival, which is this, on what? On the status of the patient. So if you do this, you have something like this. Okay, nicely done. The survival time, the A, which is those that are alive and those who are dead. Okay. And how do you compare this? Yes. How would you compare this graph? Both have outliers, right? Both are very large observations. So that's it. Both are large. They are all what? Positively skewed. If you say positively skewed, I will still be looking forward for you to tell me something more. So which means they are very large survive, or we have some who have lived longer, okay, unusually longer than majority of their group members. Okay, so that will pass for the comment and then we mark it for it. So that's it for the 5. As I said, you must comment. I'm not going back to the word to do all those things, but I'm talking about it, so you should be in a position to comment on it. Then I said plot a histogram of the survival time for the whole sample data. So still you must be working with your sample data. So I say a histogram, so hist, right? And then you can look for your survivor. So maybe myself, okay, with survival like that. I mean, I keep saying, don't leave those things for me to see. So like this, but look at the S lab, not properly done. Okay, so I have to change it. Most of you were not changing. So I mentioned this in class, but still people, so if you are doing your exam and you don't, I'll penalize you. So please take note. Survival time like this, nicely done. So you do this, you copy this on your this, and then also you copy what? The graph and put it there. But I said use relative frequencies. So what do you have on the y-axis? It's frequency. So that is what I said, change to relative frequency. And then people were dividing, and sometimes I wonder how, like the way you approach questions. You know, take your time. Look at what you did first. So you see how I've done this. Then we say use relative frequencies. How do you use relative frequency to plot a histogram? And your histogram, your x's are your relative frequencies. Is that how you plot histograms? No. You know, so your frequencies were now what you were plotting as a data. No, so which one will be your frequencies now? You get it. So once you did it, and the next thing is that use frequency, then it means you have to come here and use that frequency. And remember that we said this is for a logical value. Okay, take a logical argument. So it should be false. It shouldn't use frequency, but rather relative frequency. Like this. And now it's for density. So what you have as frequency has been changed to what? Relative frequency. If you like, you can name, okay? I can name it if I want it to appear as relative frequency, as well relative frequency, so that it is just like what you've been asked to do, like this. If I do this, it will change it from what? Density to relative. But density is the same as relative frequency. So that's that part, number 6, and that is what was required of you. So you copy this, you copy your graph, and then you show it on your Word out. Any question? Okay. Now 7 says it has been suggested that a normal and exponential distributions can be fitted to the survival time through the maximum likelihood estimate. Write functions to compute the estimate of the parameters of the okay. I think I wanted you to use normal and normal and exponential distribution, so it's fine. So normal and exponential distribution, but we are using only the maximum likelihood method. So you have to write a function to do so. Okay. So here I was not so specific, so I still mark those who use an inbuilt function. Okay. If I wanted, you could also, I saw that some attempted to write their own likelihood function and then use it, which was good and so forth. So I gave you marks, even though they were unable to do it, I still gave you some marks for it. Okay. So what do we can use the fit? It depends on you. Fit this R, because these are very simple distributions. Okay. Density function, we can use what? Is the normal and what? Exponential distribution. So we can use it, fit this out. So I copy this and bring it here, right? So I'm going to use both I'm going to use both. So what is this one? Is my survival data. So I don't expect that two people, if you are doing something, you get the same thing and show it to me, like I'm seeing in some of the things that I mark. Okay. So the first one is normal. So I look for normal distribution. I copy. Normal, right? Here. Okay. So I copy. The density function is normal. I can ignore the start station. I'll get this. Then I'll say maybe MLE dot norm. Okay. So I do this. There. So that's my estimate the mean and the standard deviation. I do the same thing, but now I have to use exponential. So I change this to what? ESP. And then here it will be what? Exponential. So I come here and I copy exponential distribution. And I paste it here. Okay. All right. Then I do this. It also gives me the rate. Okay. So that's the first part. And use them to estimate the parameters of the survival times of paging. So that's it. We are done with 7. 8, nobody attempted it. Here you have to copy your results as well and put it together with this in. Okay. Now 8 was that from your results in 7, which means your histogram, superimpose the density function of the normal and the exponential distribution using your estimates from the maximum likelihood method. Nobody was able to do it. Nobody. And what do we, it's not anything difficult. What you have here, fit, you've computed the estimate for your distribution. So fit it on this one. So it's like a frequency polygon by using the normal and the exponential distribution. Okay. So, you know, when you are doing programming, you have to think from the basis. So you start 1, 1, 1. That's what you need. This one, you are even doing it in JHS or SS as well. So how do you do this? You need the densities, right? So you need your density function. And we've talked about probability distribution now. So I have my survivor, which is my x-axis. Then it is the y's that you don't know. And how do you get the y's? You need the density. So I have to use density for the exponential, density for a normal distribution. How do I compute density functions for normal distribution? So I'll use norm, right? Remember that when we talked about, there's a video on it, probability distributions in R. We did talk about it. So D will be the density, right? So the density needs X, right? So the density is what? X, is what? So I can say let's say density normal, right, will be this. Now, what does it need? It needs X. The X is, let me just shorten this so that dense norm. So the X is your data. But remember that we found estimates for what? The standard deviation and what? And that one. So let me see. The other one was SZ. Yeah. We found the standard deviation. So for the normal, our X is what? My sample survival. Right? What is your mean? Your mean is your MLE for the normal. The mean as you find over there. Right? So I do this, then estimate, and then the 1. Or if it should be 1. Right? So the first one is a mean. I can highlight this and do it. Mean, isn't it? So the next one is what? The standard deviation. I put that one through there. Okay. So it is not everything. Most of the things you know already. It is just that when you have to do this on your own, like when you've been, if I ask you to superimpose this on a graph, you'll be able to do it. But how to think through it and say that, okay, this one is a density, this one is that's the problem. So if I do this, it's going to compute the density for each of these, if I display it. So you see all of them are values less than 1, right, in between this. So that's it. So similarly, I can do so for the density for exponential. So I do dense exponential, but that I have to use the exponential distribution. Okay. So dense exponential. So that will be what? ds. Remember the density of what? The exponential distribution. So that requires x and the rate because that one has only one parameter, right? Okay. So what do we do now? We put in x. X is what? So this is the same data. This same data. Then what is the rate? The rate will be my f, the estimate of it. Okay. The estimate. Okay, this one, it is just 1. So once we do the estimate, it will come like that. Rate. Okay. So if I do this one too, it will compute those ones. Okay. Then we say superimpose, right? Which method gives better fit? Well, some of you were using AIC and BIC. Well, that's fine. That's also good. Okay. So I marked people were using AIC, which is a function in R. If you in R, so you can use AIC and then put in your let's say your MLE whatever. So that will give you your super. Oh no, sorry. So yes, I marked them, right? But that's not really what I wanted you to do. Yes, but of course, yeah. Once you think outside the box and you're able to show me something else, I still marked it anyway. So some use AIC, BIC, which is fine. But what I wanted you to do is this. That now you see I have my plot, so I can superimpose the density on it now. How do I do so? Remember lines, right? You can lines it or use a curve, right? So lines is just like plot x and y. So my x is this zeta, the survivor. Okay. This it may not work because I may have to what is it? I may have to what do I call it? Like rank them. Okay. So let's say this one, the color is 2. You can let's see. Okay. Yes. So we need to rank them. Other than that, it will give us something like this. Okay. Who understand why we are getting something like that? Okay. It's simple. If I let me do it this way so that we avoid ranking them. You see, the sample, the survivor data is not ranked, right? If I show, let me show the first 100. Let's say 1 to let's say 10. Okay. You see, we got us 7, 3, so it's haphazard, right? So still I see my distribution here, but it is joining them because the densities have been computed. It's joining them haphazardly, but it still gives you the shape, just that the graph is not good. So what I could have done was that I could have just, let's say, sort them, right? From, if I sort it like this, it's going to be, okay, like that. This one, X is my data. Now, it's the sorted data. So 1 to 10, you realize that they will be in order. So 0, 0, 0, 0, 0, and so forth. Okay. If I do the last one, let's say the last observations, they will be more. Or if let me just display this X like this. So you see now it is arranged in order. So I can come back here and change my this one to the capital X and this one to capital X. So now if I plot, if I finish this and I plot, I'm not going to get those things again. Okay. So now I need to plot my density again before I'll be able to get it nicely done. I could have also continued by arranging it in the data frame sort of. So let me get my histogram again. And then now let me lines the normal distribution density. So that there it is. Let me increase the line width so that we see it properly. 2. Line width 2, it will make the line big. So that's it. That's how the normal distribution does it. And then now I can also do the same thing for the exponential. So here I'll just do what? Dense ESV. And then I change the color to 3. So there it is. Okay. So now if you look at these graphs, which of the distribution fits the data well? If you like, you can even put a legend, right? You can put a legend. Do you remember? So legend, will be normal, and then ESV. I am done, eh? If you have any question, what I'm doing is not part of it, just to show you that we can do all this. Exponential. Okay, and then color is equal to 2 and 3, right? And then line width, we use 2 and 2, so 2, 2. And what again? The position, let's use top left. If you want to do this, in one of the videos, I did it. So if you, legend is also good when you do something like this. So X, which we can just do it top. We can just say top. This one is should be top right, because on our top right, it must be spelled right. Yes. So we come back here. We sorry, something is wrong. Yeah, we did not put a comma here. There. So nicely done. So in your level 400 during your project, these are some of the things that will help you, okay, in presenting your work. So this is nicely done. The picture speaks for itself, right? I have survival time, I have fitted this. What will be your conclusion? Which of them fit the data better? Which one? Yes. Is it the normal or the exponential?
The normal. Exponential.
Yeah.
Exponential.
Yeah. It fits it quite better. Now, what I want you to do, okay, is that when you go home, you know what we call survival function. So we can compute the probability that we record a patient survive more than 1,000 days or whatever. Then 1,500, 2,000, 2,500. Okay. Now, when you do so, use exponential to also compute. So now the survivor will be your PS, right? Remember that this same thing, if I go to here, have you seen P? That is for what? The distribution function, which is the CDF. Remember P, if you come here, they'll say R, oh no, it's at the top. Yes, so the distribution function is the P, right? The second one. Okay, so if I change lower the tail to false, then it becomes a survival function. Do you get it? So for example, the normal, if I want to find P norm, if I want to find the probability that the patient will live more than 2,000 days, what do I have to do? I will put Q, the quantity will be 2,000, right? The mean and those things, we've already found them. How is this thing going? Okay. So P norm, the mean is what? If you remember what we use over here, let me go and copy them. There. I put it inside like this. But lower the tail, I'll set it to false, right? So that, oh, sorry. I'll set it to false so that what does it do? It computes the probability that so that's it, very small. If I change it to 1,000, the probability will increase. Have you seen? Because if we go to the plot, at 1,000, we have several people what? Who are over 1,000. That will be this thing from 1,000 onward, there are some. But if you check 2,000, only a few people lived over. If I come to 500, it will even be more. The probability will be more because we are several people over 500. You see how this is? Okay. Now, what I want you to do this for several quantiles. So maybe you simulate from 1,000 to 2,500 in steps of, let's say, 50 or 100. Okay. Then you find this using the normal, using the exponential. Then also the empirical probabilities will be that, for example, you say that so what's the data is this, right? My sample survivor, we've even made it X, so we can use X. Okay. So X greater than, let's say, 2,000. Okay. What does this mean? It means that I'll get true, false. So you see only the three observations are over that, right? So it means that if I sum this, the truths will only be the ones. So I'll get 3. Okay. Which means if I divide this by the length of X, that will give me the probability that I record observations that are greater than 2,000. Okay. So if I change this to 1,000, it will give me the probability of recording observations greater than 1,000. That is from the data. Okay. So I can compare it with the normal distribution. Okay. So from the data, it is 0.65, but the normal distribution is giving us all 0.04 or 0.03. All right. We can as well check that for the exponential. So that will be PSC. Q is 1,000. I think this is rate. The exponential, we only have rate. So we can go up there and copy. This is it. So rate is equal to the estimate. Right. Okay. Now I do this. So let me, the main value is what? 0.067, which is from the data. When we use normal distribution, we got 0.035. We use exponential distribution, we got 0.07. Which one is closer to 0.065? So the closer it is to the actual data, this thing, the better. Right? So the exponential is better, and that is what you see at the tails. You realize that the exponential fit is better than the normal distribution. So please make sure you do this for several observations, right? So what you can do is to sequence observations, right? From 1,000 to, we did this, right? Let's say 2,500 by, so maybe instead of 100. If you do this, that 100 will be so many. Let me see. Yeah. So this one, you can compute all the exceedance probabilities and use exponential distribution to compute all the exceedance probabilities. And then the normal to also compute all the exceedance probabilities. When you finish, you create a data frame, which will consist of the quantile, which are 1,000, 2,000, and so forth. And then the empirical probability, which is what you get using this sum and so forth for each point. And then that of the exponential, that of the normal. And then see which one is closer to the empirical probability, exceedance probability. So that's what you should do. And please make sure you do it before your exam time. So I'll post this on YouTube as well, so you can download and be able to go through it on your own. So thank you. Unless somebody has a question other than that, we call it a night. And then the exam, I think I won't be able to meet you again. What I said you should do is to read on the life contingencies package. You should be able to use that to find net present value and also internal rate of return. Please take your time, write your own program to be able to do a net present value and then also internal rate of return and be able to decide on an investment. Okay, strategy. So that's what you should do. I think that is all that I'll need from you. And the life contingencies, you can read about it as well. I'm not sure I'll ask you questions on that. Yeah, but I think that's all I'll need from you. So, any question? So please, tomorrow, I'll make sure we record your scripts and then you come for it. So, okay, I don't have enough people over here, but I'm giving people the benefit of doubt. Or giving you a second chance. If you know that you have submitted a paper other than what you submitted on Sakai, I am giving you the chance to own up. Okay, so you tell your colleagues. Tomorrow I'll be around. I think I'll be doing. We are doing a short course. I'll be teaching some ministry people, so I'll be on the floor. Now, maybe during our break time, you can come around. I think break will be around 12, 1 thereabout. I have noticed those who have copied. I'm also going to check those who have submitted different ones. Okay. If you own up, I know whatever I'm going to do, I will reduce it. If I don't see you tomorrow, if you copied, I will delete you from Sakai. It means you can't write the exam. So you come back next year. We'll give you F. So that's the information you should give to them. So once we share the papers, that's it. Okay, thank you. Have a good night. If you gave your whatever for somebody to copy, please own up before tomorrow. After tomorrow, that's it. Thank you. And have a good night. Bye-bye. I wish you the best in the exam. Take your time. What we have done, please sit down and go through the questions on your own and present it well. Okay? Present it as I have done, and you should be fine. And revise. Watch the videos. If you have any issues, please send me a mail. You can also come to the office and ask. If you share it on your platform, the TAs are unable to help, you can get in touch with me as well. So I wish you the best in your exam. And please make sure you don't go and do any exam or practice. Okay? Just do what you can do. Okay? It's better than going to do more practice and then you are rusticated or the paper is entirely cancelled when you could have gone with maybe a C or a B then and so forth. So don't put pieces of papers. Don't send your mobile phone, because when we take the mobile phone, it will take like a year for you to get it back. And that is after your questions, your results for the semester has also been cancelled. Yeah, so please, that's what I'll leave you with. So I wish you the best. I'll be around during the week. I think tomorrow I'll be around only on Monday, Tuesday. I'm starting invigilation, so it will be difficult for you to get me. Okay, bye bye.
One copy, but make sure